Graphing a piecewise defined function can be a little tricky, but if you consider each of the separate domains and graph each part separately, you should be all right with graphing piecewise defined functions. So first, we have the piecewise defined function x minus 2 when x is less than -1, and 10 minus x when x is greater than or equal to -1. If we ignore that second function here and just focus on x minus 2, that's just a line with a slope of 1 and a y-intercept of -2, so we could plot that very quickly. Right here, slope of 1, go up and over. And you can go the opposite way as well. All of these points fall on that line, but we have a domain restriction now. It says x is less than -1. So x is less than -1. X is -1 right here. So all the points to the left are part of our line or graph. Those are all part of our graph. And everything to the right is not part of our graph. One other thing, the point at x equals -1, it isn't equal to x minus 2. It has a less than symbol, so we'll put an open circle at that point here. Put an open circle here, and then connect the rest of them. That's what the first portion of our graph looks like. That's what our first portion of our graph looks like. Now for the second portion, the second portion, I'll do that in red. For 10 minus x, we could graph this if we just ignored all other parts. It's a line with the y-intercept at 10. So up here. And it has a slope of -1. So it goes down and over. All these points here. And we know that it's for x is greater than or equal to -1. So I have this point up here. It is a closed point because of this equal to sign. And we wouldn't put any points over here because that's not in the domain of that part of the graph. So we go right up to there and we draw our line through these points. And we have our piecewise defined function. Okay, let's do another example. Now I'll do this in the way that I usually do it. Instead of just drawing the complete thing and then erasing, it's usually a little easier to go through the whole thing in order and just be aware of that domain restriction while you're creating the graph of this piecewise defined function. So this one says for x less than -2, g of x equals 4. Okay, so -2 is here. This is -2. and it has a value of 4, so I'll go 1, 2, 3, 4, up to 4. I'll put an open circle since it's x is less than -2, and all the points to the left of that, x less than -2, those are all equal to 4. 4, 4, 4, and so on. That's a horizontal line. So we draw that. And we finish that piece of our piecewise defined function. Get rid of this circle there. Now let's move on to the second one. This is x squared plus 1 from x equals -2 up to 1. So at -2, so if x equals -2, g of x, or g of -2, equals -2 squared plus 1. This is 4 plus 1, which equals 5. We get the point -2, 5. -2 up 1, 2, 3, 4, 5 right here. We're going all the way up to 1, so I'll get the value at -1. When I plug in -1 into this equation here, I get -1 squared is 1 plus 1 is 2. So I get -1, 2 there. At 0, we get 1. At 1, we get 2. But since it's now not equal at 1, I'll put an open circle at 1, 2. Now for this piece, I'll connect the lines with a smooth curve. As smooth as possible. And that is good. So that is our piece, our second piece there. Now moving on to the third piece, we have 3 plus x, and that's for x greater than or equal to 1. 3 plus x, x is greater than or equal to 1. So if we plug in 1, 3 plus 1 is 4. And we get the point 1, 4, which is right here. If we plug in 2, we get 5. 3 plus 2 is 5. 3 plus 3 is 6. And so on. All of these points here. We connect with a straight line, or semi-straight line. Yeah, there we go, close enough. And we have our third piece here. We have our third piece there. And we've done it. We've created our piecewise defined function graph.